Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. In last class, we started acid strength of aliphatic acids. Now see the continuation. In today's class, we will get the answers for these questions. First one, what is the decreasing order of acid strength of isomers of nitrobenzoic acid? Decreasing order of acid strength of isomers of toluic acid. Decreasing order of acid strength of isomers of hydroxybenzoic acid. So before going to completion of this class, you can get answers for these questions. Okay. Now say this formic acid. Formic acid and acetic acid, benzoic acid, and phenyl acetic acid. This is phenyl acetic acid, phenyl acetic acid. Now, for these four compounds, what is the acid strength order, decreasing order for acid strength for these compounds? So, in this no electron donating group, no alkyl group is present. That's why this compound can donate H plus ion easily compared to remaining compounds. Hence, this acidic strength is more. HCOOH, formic acid, greater than. Next one is benzoic acid, C6H5COOH. Because in this, C6H5 is a weak minus I group. So it can withdraw electrons from COOH. It can decrease the electron density from the attached COOH group and increases its acidic strength. Next one is C6H5CH2COOH. Last one is CH3COOH. In this, C6H5 is a weak minus I group, but it is not attached to COOH directly. In between C6H5 and COOH, CH2 group is there. CH2 group is a electron donating group. So its acidic strength is less than these two compounds. And finally, in this alkyl group is there. CH3 is a electron donating group. So its acidic strength is very less than remaining three compounds. So this is the order for these four acids. Formic acid, HCOOH greater than benzoic acid. C6H5COOH, benzoic acid greater than C6H5CH2. COOH greater than CH3COOH. Now, see the acid strength for substituted benzoic acid, aromatic acids. Acid strength of aromatic acids. Aromatic acid means COOH group attached to the benzene ring, that is called aromatic acid. Example, benzoic acid. This is the formula, structural formula of benzoic acid, C6H5COOH. Now, on this benzoic acid, substituents are there. Then what is their acidic strength? Electron donating substituents, electron withdrawing substituents. Two types of substituents are possible. Which type of substituents can increase the acid strength and which type of substituents can decrease the acid strength, we will see. Say this, just like aliphatic acids, electron withdrawing groups or electron withdrawing substituents increase the acid strength. Increase the acid strength of substituted benzoic acid. And electron donating groups or electron donating substituents decrease the acid strength of substituted benzoic acid. Now see the example. electron withdrawing groups means NO2Cl, chlorine, nitro group, and CN, these type of groups. Electron donating means alkyl groups. Now see the order. Benzoic acid having NO2 group at para position, and chlorine atom at para position. Benzoic acid without any substituent, and electron releasing group CH3 at para position. For these compounds, acid strength order, if we see that NO2 is a electron withdrawing group, its electron withdrawing nature is more than Cl, so it has more acidic strength than this one, which is more than benzoic acid, it is more acidic strength than this one. So these are electron withdrawing group, this is electron donating group. So in this way, electron withdrawing substituents are present on the benzoic acid, their acidic strength is more than benzoic acid. Electron donating groups are present on the benzoic acid, then its acidic strength is less than benzoic acid. Okay, now electron withdrawing group increases the acid strength, of para isomer than its meta isomer. In aromatic acids, we can get isomers, ortho form, para form, meta form. I mean ortho isomer, para isomer, meta isomer. In all these three forms, ortho isomer is more acidic than para and meta form. This is due to ortho effect. Ortho form, ortho isomer is more acidic than para and meta forms. So due to ortho effect, ortho isomer is more acidic than para and meta isomers. Now what is ortho effect? Ortho effect means either electron withdrawing group or electron donating group is at ortho position. Either electron withdrawing group or electron donating group is at ortho position, then its acidic strength is more than para and meta forms. For this reason is due to steric hindrance and electronic factors. Irrespective of the nature of the substituents, whether electron withdrawing or electron donating, ortho isomer having more acidic character than para and meta forms. And come to the para isomer, meta isomer. In these two forms, which one having more acidic character when electron withdrawing groups are present? Para isomer having more electron withdrawing group than meta isomer. Remember this point. First ortho isomer, and then remaining para and meta forms, then para isomer, then meta isomer, then benzoic acid. So ortho isomer having more acidic character than para isomer, which is more acidic than meta isomer, which is more acidic than benzoic acid. So highest acidic strength for ortho isomer, least acidic strength for benzoic acid. Now take an example. Nitrobenzoic acid. Nitrobenzoic acid. In this nitrobenzoic acid, we can get ortho, para, meta forms and benzoic acid. For these four structures, the order is this one. Ortho form having more acidic character. This is ortho nitrobenzoic acid. More acidic character than para. Which is more acidic than meta, which is acidic than benzoic acid. Okay, so here due to ortho effect, it is more acidic. Come to the para form. This is para form. This is meta form. In para form, NO2 group can exhibit minus R and minus I effect. Minus I effect means negative inductive effect. Minus R effect means negative resonance effect. Resonance, this topic you will learn in the next session, next class. Now just remember resonance. Here, just like inductive effect, resonance effect is also two types, minus R effect, plus R effect. Minus R means negative resonance effect, plus R means positive resonance effect. Here in this para form, NO2 group can exhibit both negative resonance effect and negative inductive effect. But in case of meta form, weak minus I effect is there. Between resonance effect and inductive effect is weaker than resonance effect. In para form, two types of effects we can observe, but in meta form, only negative inductive effect is operating. So its acidic strength is less than this one. So this is the order. Next, see the next one. Electron donating groups decreases the acidic strength of para isomer. Decreases acidic strength of para isomer more than meta isomer. Already we know that electron donating groups decrease the acidic strength of the para isomer and meta isomer. In these two forms, para isomer acidic strength is more decreased than meta isomer. That means meta isomer is more acidic than para isomer. See the example here also. Take the three isomers of the aromatic acid. Toluic acid. Toluic acid means this is the structure. COOH having CH3. This is ortho form, ortho isomer, ortho toluic acid. So in this compound also ortho isomer having ortho effect. That's why its acidic strength is more than remaining two isomers. This is ortho toluic acid. It is more acidic than ortho effect. And come to the next. Remaining two, para and meta forms. For this toluic acid, CH3 is a electron releasing group, electron donating groups. Due to this electron donating nature, para and meta forms having less acidic than benzoic acid. Benzoic acid, and between meta and para isomer having least acidic nature than meta. This is metaform. This is paraform. Here in orthoisomer, CH3 can also exhibit hyperconjugation. Just remember this term. In the coming classes you can learn what is hyperconjugation, all these things. So due to this ortho effect and also hyperconjugation effect, orthoisomer having more acidic character than remaining two forms, benzoic acid having more acidic character remaining two para and meta forms, because it is a electron donating group. That's why benzoic acid having more acidic character than these two. Between these two, in meta form, hyperconjugation is not operating. Hyperconjugation is not operating. So its acidic strength is more than para form. So remember reasons carefully. Due to ortho effect and hyperconjugation effect, ortho form having more acidic character and meta form, para form having electron donating group. So their acidic strength is less than benzoic acid. In these two forms, meta form does not having hyperconjugation, so its acidic strength is more than para form. So this is the order for acidic strength of toluic acid. Next, see the next one. Acidic strength for hydroxybenzoic acids. Hydroxybenzoic acid. Structure is this one. Structural formula COOH and OH. This is orthohydroxybenzoic acid. Orthohydroxybenzoic acid. Now in this case also ortho form having ortho effect. That's why its acidic strength is more than remaining two para and meta forms. Ortho form, this one, it has ortho effect, so its acidic strength is more than remaining two forms. Here in meta form only minus I effect is operating. Only minus I effect is operating in meta form, so its acidic strength is more than benzoic acid. Only minus I effect, and least acidic character is for para form. Here para form, in this para form OH group exhibiting strong plus R effect, electron releasing nature to the attached conjugated system. Positive resonance effect. Positive resonance effect or plus R effect is observed for para isomer of hydroxybenzoic acid. That's why its acidic nature is less. So the acidic strength order for hydroxybenzoic acid, ortho form greater than meta form greater than benzoic acid greater than ortho para form. Okay. So in the beginning of this class we have three questions. For these three questions we got the answers. So first one is decreasing order for acidic strength of nitrobenzoic acid. Say this: nitrobenzoic acid decreasing acidic order. Next one is decreasing order for toluic acid. So this is the toluic acid acidic strength order. Last one is hydrobenzoic acid acidic strength. Okay students, practice well, remember carefully. We'll meet you in the next class.